Here's a nice little application problem on finding surface area and volume. We've got a grain silo. Says a farmer builds a grain silo on a flat concrete floor. The silo consists of a cylindrical base, which is 40 feet high and has a diameter of 6 feet. So this is a cylindrical base. Has a diameter of only 6 feet. It's all the way across. Let's just fill that in. That would look like 6 feet all the way. If you went straight across, that would be 6 feet. And that gives us a radius of 3 feet, we know, right? And then a height of 40 feet. We've got this radius of 3 feet and a height of 40 feet. Now, that means if the radius is 3 feet, it tells us that it's got a hemisphere-shaped roof. So, of course, that would be 6 feet all the way across the top. So this radius is also 3 feet. Okay, and this is a hemisphere. So the first thing it asks is, if the farmer wishes to paint the outside of his silo, including the roof and door, how many square feet will he need to paint? Give both the exact answer and an approximation using the fact that pi is approximately 3.14. So we have to paint this, that is a question to deal with surface area. So we're looking for the surface area. We've got a cylinder, right? This is cylindrical. It's the cylindrical base. And then this is a hemisphere or half sphere. I'm going to write half sphere. That's what hemi means, is half. So, hemisphere. So there we go. Let's write that a little more neatly. So, surface area of a cylinder. Now, it tells us here that the surface area of a right circular cylinder is 2 pi rh plus 2 pi r squared. Now, in the last video, I commented that this 2 pi r squared is two of the bases. Now, in a right circular cylinder, you have a bottom and a top that are both circles. And so, the top area is pi r squared. And the bottom area is pi r squared, and that's where we get the 2 pi r squared from. In this application problem, you're not painting the bottom, that's a concrete floor, and there isn't like a ceiling on this. This is just the hemisphere, the curved roof. So we are not actually going to find the surface area of a complete right circular cylinder, but just what's called the lateral surface. The side here, which is 2 pi rh. So let's clarify that. So we're going to do two parts. We're going to have what we're going to paint. The painting area is what we're looking at, really. It's the surface area. Is really just the 2 pi rh. That's this part of the surface area of a right circular cylinder. And it's a hemisphere. So notice the surface area of a sphere is 4 pi r squared. So we're going to add that half of 4 pi r squared, which of course is just going to be 2 pi r squared, is half of 4 pi r squared. So we're going to use this formula. We know that our radius was 3 feet and our height was 40 feet. So here we go. 2 times pi times 3 times 40 plus 2 times pi times 3 squared. Now these are all in feet. So this really would be 3 feet times 40 feet, and that's what's going to give us square feet when we're for our unit at the end. So 2 times 3 is 6, and 6 times 4 is 24, and tack on a 0 for 40, so that's 240 pi. And then 2 times pi times 3 squared. Now 3 squared is 9, and 2 times that is 18, so that's 18 pi. So that gives us 258 pi. Take yourself a moment and calculate that. So this is our exact answer. Our approximation is when we plug in 3.14 times for pi. So that gives us 810.12. So there are our two answers. 258 pi, which we wouldn't really be very practical leaving it in that form, so we'll approximate it as 810.12. I think reasonably we'd round that off to 810, or even say like about 800 square feet, or you could round it up to 1,000 depending on how you want to calculate that paint. So that's our painting area. Now our volume is how much it could contain, right? This is the next question, is how many cubic feet of grain, that's cubic feet is a volume, three-dimensional measurement. How many cubic feet of grain can he store in his silo if he fills it to the top? Okay, well, that's a pretty full silo. Oftentimes this is left open practically, but this is just for our sake of doing practice. So we want the volume of a right circular cylinder. Now, the volume doesn't change with whether you don't have a top or bottom on it. The circular top or bottom doesn't change the volume. So the volume of that cylinder we had before, we have a cylinder and we have a hemisphere. And the volume of the cylinder is pi r squared h. And the volume of a sphere is 4/3 pi r cubed. Oops. But it's a hemisphere, so I'm going to multiply that by a half. Half of 4/3 pi r cubed. So that's let's plug in our values there. Pi times 3 squared times 40 plus, now 1/2 times 4/3, that 2 and the 4 could actually reduce to 1 and 2. So that's going to actually give us 2/3 pi times 3 to the third power. Doing that calculation, 3 squared is 9, and 9 times 4 is 36, so that's 360 pi. And now, I'm going to go over here to the side. You've got a 2/3, we know we're going to get pi here. We got a 2/3 times 3 squared, which is 27. Now you could have reduced a little sooner, but the 3 and the 27 were reduced to 1 and 9. They're both divisible by 3. So that gives us 18 pi. So we have 360 pi plus 18 pi, which is 378 pi. So that's our exact value for that volume. And to find the approximation, we plug in 3.14 for pi and approximate that. So take a second to do that on your calculator. So I calculated that and got 1,186.92. Seems reasonable. 378 is a little less than 400. 3 is a little more, 3.14, a little more than 3. 400 times 3 would be 1,200. So that's about right. It's reasonable. Of course, I would round that off, practically speaking, but I'm not sure. There was no instructions on rounding here. So I'll just write using the 3.14. 1186.92 cubic feet of grain. Okay, I hope you found that video helpful.